Hello fellow programmers, today we're continuing our React Native project. This is part 2 of the tutorial series. In this session, we'll cover a lot, including building cross-platform apps with Expo, implementing navigation, working with alerts and local storage, integrating AI for meal recommendations, and much more. The only prerequisite for this project is a basic understanding of React Native. Now, let me show you what I've built. On the home page, you can see all the statistics are now reset. So let's move to the meal page and begin setting up our profile. When we click on the Complete Profile Setup button, we will be prompted to fill in our basic information. We'll start with our basic details such as name, age, and gender. Once that's complete, we'll click on the Next button. For the physical statistics, we will enter our current weight and our height. After entering those values, we'll click on the Next button to proceed. On the activity level and goal screen, we will select our activity level and our primary fitness goal. When we scroll to the bottom of this screen, we can immediately see our target calories, which have been calculated based on all the information we just added. Let's click on the Next button. If you have any dietary preferences, you can add them here, and then you can click to complete the setup. Now that the basic profile is configured, we can click on Generate AI Recommendations. This is where the Gemini AI will come into play, coming up with a recommended diet plan tailored specifically for the user, based on the information we just uploaded and added. On the AI recommendation screen, we can see all the user's input information, along with a couple of meal options for breakfast, lunch, supper, and snacks. You'll also see the estimated nutrition profile and calorie count for each option. Now, when I click on the plus icon next to the breakfast option, I'll be able to select the specific meal the AI planned for me for breakfast. So I'm going to go with oatmeal with berries and almonds for breakfast. I will repeat the same process for lunch, and for that, I will select Greek yogurt with honey and granola. For a snack, I will go with a smoothie bowl with banana and berries. And finally, for dinner, I will select whole grain toast with avocado and eggs. Ideally, you are supposed to be adding them as you consume them throughout the day. Now, going back to the home page, we can see that our statistics have updated for calories, protein, and carbs based on the meals we just selected. On the meals page, we can see we have all the options for breakfast, lunch, and all the rest of the meals set up here. The profile page shows the current static data for now, as the information is not currently coming from a local storage or a database, which is something you can work on later. Finally, on the settings page, we have the AI configuration, which is where we will store our Gemini AI API key. According to YouTube Analytics, most of you who watch my videos are not subscribed yet. Please consider subscribing and hitting the like button. I am excited to introduce my first software as a service project called I Built This. I Built This is built for developers who want to escape tutorial hell. Learning to code is just one piece of the puzzle. You need real projects with real teams. I Built This is about quality, hands-on projects. We have a couple of projects on the platform which have AI recommendations based on your interests and learning goals, which you inputted during onboarding. The projects are also categorized into different fields. We have web dev, mobile dev, AI and machine learning, and gaming. We have a couple of daily and weekly challenges you can have your hands on to practice and improve your coding skills. This project is one of the ones I built a couple of months ago, so I will click on it and build it with the help of I Built This. After joining the project, we set it up and then start building. On the task page, we can use AI to generate tasks, and if they're good, we assign them to ourselves. So I will assign a couple of tasks to myself and click on the Complete Setup button. Then we move to the project details page. On this page, we have the project progress, the tasks, and we can update the project settings, like the project timeline and other features. So let's add a new milestone to the project by clicking on the project settings button. On this modal, we add a title and due date for the timeline and save it. And we have it here. On the task page, we have all these statuses which you can drag to a different state based on the current task you're working on to keep track of your progress. Let's talk about challenges. On the challenges page, let's say I am interested in this challenge called longest substring without repeating characters, and choose to join this challenge using the join challenge button. Now upon joining, we are taken to the dashboard. On this dashboard, we can work on the challenge in real time with our inline code editor. If your code satisfies all the test cases, you can publish it for others to have a look or get inspired by your solution. Not only can you work on the coding challenges, but you can also work on the design challenges. These challenges give you access to code and allow you to see changes in real time, as you can see on the dashboard right now. You have the ability to toggle between the design you are building and what you have built so far. If you are satisfied with your solution, you hit the publish button and you are good to go. You can also save your code and continue later anytime you are ready. On the dashboard, we have the chat feature for projects that need more than 2 teams. Everyone gets the message, it broadcasts to everyone. On the project metrics section, we have your total projects, challenges, total activities, and contribution scores. This is a project that will genuinely change the way beginners and even professional software engineers enhance their skills. If this sounds amazing, kindly visit ibuildthis.com and start working on a project now. Follow us on socials, on Twitter, TikTok, and YouTube. Links are provided in the description. Now, we are about to install Expo. What exactly is Expo and what is it used for? For a long time, developers needed to learn either Swift or Kotlin or Java in order to build apps for iOS and Android respectively. This approach made scaling and testing new ideas quite expensive. You would have to learn a new language and build 2 separate apps, which not only consumes time but also resources, and not to mention how long it takes to learn these technologies. So Facebook came up with React Native, a framework to help JavaScript React developers pivot to building mobile apps easily and quickly with a small learning curve. And it's great because it can build both iOS and Android. Down the line, React Native still needed some small tweaks when using certain native components from both platforms. For example, if you want to access the gyroscope on iOS, you would typically need to access the iOS build file and write some configuration over there. So Expo came along and hid those abstractions, allowing developers to build on what truly matters. Expo is essentially a wrapper around React Native to help developers access native functionalities easily and make the entire developer experience smooth. Before we start building the meal plan context, we absolutely need a reliable storage service to persist our users' data. We're going to create that service now and then integrate it later. So let's start by creating a new directory called services, and inside that we'll create a new file called storageservice.ts. This is where we'll write the code for our singleton storage service. We're building a reliable storage solution for our application using the singleton pattern, which ensures only one instance of our service exists globally. We'll use Expo Secure Store because it provides platform-specific encrypted storage for sensitive data like API keys and user preferences, which is much safer than regular local storage. So let's start by typing the necessary import. Import star as secure store from Expo Secure Store quote semicolon. Now we'll define a few TypeScript interfaces to clearly specify the shape of the data we'll be storing. This helps us ensure type safety throughout the application. First, the personal info interface, which holds all the user's detailed health and goal information. We type interface personal info open curly brace, then list the properties: name :string semicolon, age :string semicolon, gender :string semicolon, weight :string semicolon, height :string semicolon, activity level :string semicolon, goal :string semicolon, dietary restrictions, allergies, and finally target calories :string semicolon. This last one will be calculated automatically based on the other data. Next, the meal interface, which represents a single planned meal: ID title :string semicolon, time :string semicolon, food any semicolon, and has food boolean semicolon close curly brace. The food property is optional, signified by the question mark. Now, we define our storage service class. We type class storage service open curly brace. Since we are enforcing the singleton pattern, we need a private static property to hold the single instance of our class. We type private static instance : storage service semicolon. Next, we define our storage keys as private read-only properties. These string literals are the unique identifiers we use to save and retrieve data in Secure Store. We type private read-only personal info key =, personal _info. Next, private read-only meals _key =, meals _data. Then, private read-only Gemini API. And finally, private read-only first time user =, first _time _user quote semicolon. To finalize the singleton pattern, we make the constructor private. We type private constructor. This prevents external code from using the new keyword to create multiple instances. The access point for our service is the static get instance method. We type static get instance storage service. Inside, we check if the instance has already been created. If not, storage service.instance. If not, we create it. Storage service.instance, new storage service, then we return storage service.instance. Alright, now let's implement the core storage logic, starting with personal information storage. The save personal info method is asynchronous because saving data to Secure Store is a non-blocking operation. We type async save personal info and open curly brace. In the try block, we use await Secure Store dot set item async. This dot personal _info key JSON dot stringify. We JSON stringify the object because Secure Store can only store strings. We include a catch block for error handling. The get personal info method is also asynchronous to retrieve the string data. We type async personal info, open curly brace. In the try block, await secure store dot get item async. This dot personal underscore info underscore key. We then check if data exists, and if so, we JSON dot parse it back into a JavaScript object. We type return data JSON dot parse. To remove this data, we define async clear personal info. We use await secure store dot delete item async dot personal info underscore key. The meals data storage methods, save meals, get meals, and clear meals, follow the exact same pattern but use the meals underscore key. They also require JSON.stringify and JSON.parse. Because we are storing an array of meal objects. We continue this pattern for the Gemini API key storage methods. Save Gemini API key, get Gemini API key, and clear Gemini API key using the Gemini underscore API underscore key. Then, the methods for the first time user flag. Set first time user, which saves a boolean, and is first time user, which retrieves it, defaulting to true if no value is found. We implement clear all data to reset all user data in one go. We use promise.all to execute all the clear operations concurrently, making the process much faster. Finally, we have utility methods. Has completed setup simply checks if personal info exists, returning a boolean. Get storage stats uses promise.all to quickly fetch the status of all 4 keys, providing useful information for the settings screen or debugging. And we finish the service by exporting the single instance. Export default storage service dot get instance open. Now, back to the meal plan context page. We are going to import the storage service we just created and set up our application's central state management using the context API. We start by importing our service. Import storage service from services/storage service. Next, we import the necessary hooks and types from React. Import React create context, React node, use context, use effect, use state from React. Before defining the context, we need to ensure type safety by defining the necessary interfaces again in this file. We define food item to detail the nutritional breakdown of a single food item. The meal interface is defined again here, matching the one in the storage service. Then, nutritional data for tracking the daily consumption goals. The personal info interface is also defined here, ensuring we have the correct type definition for the user data. Now, we define the meal plan context type, which specifies everything that will be available when a component consumes this context. This includes state variables like meals and personal info, and all the functions like update meal, remove meal, and all the storage methods. We create the context object. We initialize it with undefined because the default value won't be used, but it's required by the API. We define the provider's props. Now let's define the main component, the meal plan provider. We set up the meal state with an initial array of 4 standard meal slots and list the 4 default meal objects: breakfast, lunch, snacks, and dinner, all with has food set to false close parenthesis semicolon. We also set up the initial nutritional data state with placeholder values. Next, we define the calculate target nutrition function. This function is essential because it uses the user's target calories and goal to dynamically determine the recommended macronutrient split, protein, carbs, and fat, adjusting the ratios to help the user achieve their specific goal, whether it's to lose, gain, or maintain weight. We initialize personal info and its loading states. We use a use effect hook to run the load initial data function only once when the component mounts. This hook is vital for retrieving any saved data when the application first starts up. The load initial data async function uses the storage service we built. It first sets its loading to true. Then it attempts to load personal information. If successful, it not only sets the state, but also immediately calls calculate target nutrition to set the user's daily goals. Next, it loads any saved meals. Finally, it sets its loading back to false. This sequence ensures the API doesn't try to render data before it's fetched. The update meal function takes a meal ID and a food item. We update the state using the set meals state setter. We pass it a function that receives the previous meals array, then we map over it. If the meals ID matches the one passed in, we return a new object using the spread operator to keep the existing meal properties but update the food and set has food to true. If they don't match, we return the original meal object. Now we continue with the remaining functions. The remove meal function is very similar to update meal but sets food to undefined and has food to false. The add custom meal function creates a new food item object from the inputs, assigns it a unique custom ID based on the current time using date.now, and then simply calls update meal to integrate it into the meal plan. The clear all meals function iterates over all meals and resets their food and has food status to clear the plan for the day. The get total nutrition function is key for tracking progress. It doesn't modify state. It's a pure calculation. It uses the reduce method on the meals array to efficiently iterate through all meals and accumulate the total calories, protein, carbs, and fat consumed so far, starting from a base of 0 for each. The remaining methods save personal info, load personal info, clear personal info, has completed setup, save meals to storage, and load meals from storage are all direct wrappers around the storage service functions, ensuring that every time we interact with persistent storage, we also update the local React state. For example, save personal info updates the local state and then immediately calls calculate target nutrition to update the nutritional target displayed to the user. We add an important use effect hook at the end to implement the auto-save feature. This effect watches the meal state and the is-loading state. When meals change, we call save meals to storage, but we use the if not is-loading check to prevent the autosave from running immediately when the component mounts and trying to save the default empty meal list before the real saved data has loaded. We define the value object which bundles all the state and functions into one object that will be passed down through the context. Finally, we return the meal plan context.provider component, passing the value object with children inside. This makes all the context state available to any child component. Now back to the index page of the home screen, where we will consume the context and render the data. We import the use meal plan context hook that we just created. We use the structuring to pull the key pieces of state and the function we need from use meal plan. We type we create a variable named total nutrition, which holds the result of calling the get total nutrition function. Then we scroll all the way down to the metric card components, which display the user's progress against their goals. We will update the value and target value props dynamically. For the calories card, the current value is set to total nutrition.calories. and the target is nutritional data.calories. This allows the card to show progress toward the daily goal calculated by the contest. We repeat the same pattern for the protein and carbs cards, setting the current value to total nutrition.protein and the target to nutritional data.protein. And similarly for carbs, we'll also change the icon type and colors to visually differentiate them. Now, at the meal section placeholder, we are going to dynamically render all the meals. Since we want a 2-column layout, we will split the 4 meals into 2 separate rows of 2. We type the main view wrapper. Inside, we create the first row's view. We use meals.slice.map to get the first 2 meals, breakfast and lunch, and iterate over them, rendering a meal card for each one, passing the unique meal.id as the key and the meal object itself as a prop. Then we create the second row's view. We use meals.sliceopen parentheses 2,4 close parentheses .map to get the remaining 2 meals, snacks and dinner, rendering another set of meal card components. Finally, we close the main view wrapper. Now we have the list of meals rendering. To complete the look, we need to apply some styles. We'll add the following styles to our styles object: meals, container, horizontal 24 gap 16. This gives the whole section spacing. Meal row colon, open curly brace flex, direction colon, row gap 16. This sets up the side-by-side layout for 2 cards in a row. Meal card. This sets the base look for each card. We add more styles for the content: meal header, meal title, meal time, and meal food. We then apply these styles to the views. We add the meals container style to the outermost view. We add the meal row style to the first inner view, and we add the meal row style one more time to the second inner view. Back to the actual meal card component JSX, we will add the meal card style to its container view, then the meal header, meal title, meal time, and meal food styles to their respective text and view components. And we can see it rendering beautifully at the right side of the screen. This looks great and awesome. Now let's work on the meal page. This is the page that will be responsible for displaying all the meal setup. We will create a new file inside the tabs directory called meals.tsx. And we would need an additional component to hold all the logic for the AI recommendations. So let's move to the components folder and create a new file called AI food recommendation.tsx. In this file, we're going to rely heavily on a service that manages our AI connection. We need a place where we can store all the AI services, like adding the API key and removing it. Inside the services directory, let's create a new file called Gemini service.ts and define our AI service there. Now, in the terminal, we are going to first install the Google Generative AI package. The version we will be installing is the Google/generative-AI at 0.24.1. Let's install this exact one so we are all on the same page. We are building a dedicated service to interact with the Gemini API. This centralizes all AI logic, making it reusable and separating it from our components. So let's start by importing the core library. Import open Google Generative AI from Google Generative AI. We'll define a few interfaces to ensure the data flowing into and out of our service is strongly typed. We define personal info and food item to match the structure we've used in the other services. Now we define the Gemini service class. We type class Gemini service open curly brace. We'll use 3 private properties to manage the AI instance. Private Gen AI colon, Google Generative AI vertical bar, null equal sign, null semicolon. Private modal colon, any equal sign, null semicolon. And private API key colon string vertical bar, null equal sign, null semicolon. We initialize them all to null. In the constructor, we intentionally do nothing. The reason we don't initialize here is because the API key is sensitive and must be loaded asynchronously from our secure store when the app starts, not at the service's creation. The set API key method is crucial for configuration. We type set API key. First, we perform validation to ensure a key is provided. Then we set the internal desktop API key. We then initialize AI instance. We select the model we will be using for real generation. We use generative model 2.5 Flash from Gemini AI. We choose generative model 2.5 Flash because it's fast and effective for structured test-based tasks like this. The core of the service is the generate meal recommendations method, which is asynchronous. It takes the personal info, the desired meal type, and the current meals consumed today. We need all this data to make a truly personalized recommendation. Inside the try block, we first check if the API key has been successfully configured. If not, we throw new error instructing the user to go to settings. Then, we build the prompt. This function constructs a detailed request for the AI. Next, we call the API, we extract the response text and then pass it. Return this dot pass AI response. In the catch block, we handle any errors. We have specific logic to check for API key errors or service unavailable errors like modal overloaded or quota exceeded, and throw helpful user-facing error messages instead of technical ones. If the error is unrecoverable, we call this .get fallback recommendations to ensure the user always gets a list of meals. The build prompt private method is where the magic happens. It takes all the user data and constructs a detailed multi-line string. First, it calculates the remaining calories. Then, it uses a rich system prompt. You are a professional nutritionist and chef to set the AI's persona. We include the full user profile and current nutrition status. The requirements section explicitly tells the AI to generate exactly 5 meal options, consider dietary restrictions, and only return a JSON array with specific fields. This strict formatting is essential so our app can reliably parse the AI's output. We have a calculate current nutrition method, which uses the reduce function on the meals array to sum up the calories and macronutrients consumed so far. The parse AI response method attempts to extract the JSON array from the AI's raw text response using a regular expression to ensure we don't accidentally include any introductory text the AI might generate. If successful, we use JSON.parse and then map over the result, applying defaults and casting types to ensure the returned food item array is correct and reliable. If parsing fails, we fall back to generic recommendations. The get fallback recommendations method provides a set of hard-coded meal ideas for breakfast, lunch, dinner, and snacks. This acts as a safety net if the AI is unavailable or an error occurs. Each fallback meal is fully structured as a food item. Finally, we include 2 utility methods: is API key configured and get API key. We export a new instance of the service. Export default new Gemini service, open parenthesis, close parenthesis, semicolon. Now let's move back to the AI food recommendation component. We are going to import the Gemini AI services we just created. Import Gemini service. from @services/Gemini service. We also need our storage service and meal context. We import the storage service and the use meal plan context hook. We start by importing the necessary React Native components and hooks. We define the food item and personal info interfaces again for local type checking. We define the AI food recommendation props interface. This component is designed to be a modal, so it needs a visible boolean, an onClose function, an onSelect food function to send the chosen meal back to the parent screen, and the selected meal type. We define our functional component, AI food recommendation, and destructure the props. We set the default selected meal type to breakfast. Inside the component, we set up several state variables using useState, show personal info modal, recommendations, an array of food item, is loading, personal info, has API key, and has completed setup. We're using local state here to manage the flow of this modal. We use meal plan to get the global meal state, which represents today's consumption. The check setup status and check API key async functions are essential for managing the AI workflow. Check setup status calls the storage service to see if the user has completed their profile. Check API key loads the API key from storage and, if found, calls Gemini service.set API key to configure the AI service. If configuring fails, it sets has API key to false. The load personal info function simply fetches the user data from storage. The useEffect hook runs whenever the modal becomes visible. We check the setup status, API key, and load personal info. This ensures the modal is always synchronized with the latest settings before displaying recommendations. The handle, personal info, complete async function is the callback we'll use when the user finishes the setup modal. In the try block, we save the personal info, update local state, and check the API key again. We then include an alert.alert block to prompt the user to enter their API key in settings if they haven't already. If everything is good, we automatically call generate recommendations. The generate recommendations async function is the core logic. First, it checks for personal information, then it sets is loading to true. In the try block, we call the Gemini service dot generate meal recommendations function, passing the required data. The response is saved to the recommendation state. The catch block handles errors, again using alert.alert to notify the user of issues with the API key, or if the service is busy, providing options to either go to settings or use fallback recommendations. The get fallback recommendations function is defined locally here as well to structure the hard-coded meals into the food item interface with unique IDs, making them usable by the component logic. This provides a clean separation from the service's fallback logic. The handle, select food function, takes a selected food item, passes it up to the parent component via onSelect food, and then calls onClose to dismiss the modal. The food card component is defined as a small functional component to render each recommended meal. It's a touchable opacity with an onPress handler that calls handle select food. Inside, it displays the food.name, calories, protein, carbs, and fat in a structured view layout. The render content function uses a conditional check to determine what to display inside the modal. The first check is if show personal info modal is true. We return the personal info modal component. We don't have the personal info modal component yet, so let's explain what it will be used for. The personal info modal will be a dedicated component responsible for collecting all of the user's detailed information, like name, age, weight, goals, and allergies in a guided multi-step process. Once the user completes the form, it will call the handle personal info complete function we just wrote to save the data and kick off the AI meal generation. Now, in the components directory, let's create a new file called personalinfo modal.tsx. So let's dive into the personal info modal, which handles our multi-step user setup. The goal is to collect all the data needed for our AI food recommendation engine. First, we import the necessary components. We are using ionicons from the Expo vector icons package, and from React, we need use state. Then from React Native, we are importing alert, modal, safe area view, scroll view, style sheet, text, text input, touchable opacity, and view. Now let's define our core data structure with a TypeScript interface called personal info. It includes fields for name, age, gender, weight, height, activity level, and goal, all of which are strings. We also have two arrays of strings for dietary restrictions and allergies. Finally, target calories is a string that will be calculated automatically based on the user's data. Next, we define the personal info modal props interface to specify the properties for our component. We need visible, a boolean, onClose, a function with no arguments that returns void, and onComplete, a function that takes the completed personal info object and returns void. Now we define our main functional component, personal info modal. We'll use the fat arrow syntax here. Inside the component, we set up our state. We need current step, initialized to 0, and personal info, which holds all the user data. We use useState for both. For personal info, we initialize all the required fields to empty strings or empty arrays, name : empty string, age : empty string, and so on. We explicitly set target calories to an empty string because it will be calculated later. We also need two local state variables to handle custom input, dietary restriction input and allergy input, both initialized with empty strings. Next, let's define the content for our steps in an array called steps. We'll use simple strings, basic info, physical stats, activity and goals, and dietary preferences. We'll define data arrays for multiple choice options. The activity levels array contains objects with label and value pairs. We have 5 levels in total, from sedentary up to extremely active. Similarly, we define a goals array with options like lose weight, maintain weight, gain weight, build muscle, and improve health. Then we have a predefined list of dietary restrictions like vegetarian, vegan, and gluten-free. Let's implement the navigation handlers. The handle. Next function checks if the current step is less than steps.length minus 1. If it is, we increment the current step. Otherwise, we call handle complete. The handleback function checks if the current step is greater than 0 and, if so, decrements the current step. The handle complete function is crucial. First, we perform validation. We check if all required fields are filled using a long logical OR condition. If any are missing, we show an alert.alert saying missing information, and then we return. After validation, we automatically calculate the target calories. We declare a constant calculated calories and set it equal to the calculate target calories function call. Then we create a new object called final personal info by spreading the existing personal info and updating the target calories key with the calculated calories dot to string function. Finally, we call the onComplete prop, passing in final personal info. Now let's define the calculate target calories function, which returns a number. We pass the string values from personal info dot age dot weight and dot height into numbers using parseInt and parseFloat. We start with the BMR calculation, using the Mifflin-St. Geo equation. We set let BMR equal sign 10 times weight plus 6.25 times height minus 5 times age semicolon. Next, we adjust for gender. We define the activity multipliers object with corresponding numeric values for each activity level string. We calculate the total daily energy expenditure, or TDE, by multiplying the BMR by the correct multiplier based on the user's activity level. Finally, we adjust the TDE based on the user's goal using a switch statement. For example, if the goal is lose weight, we subtract 500 for a calorie deficit. If the goal is gain underscore weight, we add 300 for a surplus. We finish by returning math.round open parenthesis TD close parenthesis. We need functions to manage the dynamic selection of restrictions and allergies. Toggle. Dietary restriction takes a restriction string. We call set personal info, spreading the previous state, and then update the dietary restrictions array. We check if the restriction is already included. If it is, we filter it out. Otherwise, we spread the array and add the new restriction. To allow users to add custom input, we create add custom dietary restriction. We check if dietary restriction input .trim is truthy. If so, we update personal info .dietary restrictions with the new trimmed value and then reset set dietary restriction input to an empty string. Add custom allergy is a parallel function for allergies. Next, we define the render step function, which uses a switch statement on current step to render the correct part of the form. Case 0 is for basic information. Inside the container view, we have a title and a description. We render an input group view for name star with a text input component. We pass the value from personalinfo.name and use the onChange text prop to call set personalinfo, spreading the previous state and setting name to the new text. We set the placeholder to enter your name. We repeat this pattern for age star, setting the keyboard type to numeric. For gender star, we use a radio group view. We render two touchable opacity components, one for male and one for female. The styles are conditionally applied based on whether personalinfo.gender matches male or female, allowing for active button and circle styles. The onPress handler updates the gender state accordingly. That concludes step 0. Case 1 is for physical statistics. Here we need the weight and height. We follow the same input group and text input pattern, setting keyboard type to numeric for both and updating weight and height in the state respectively. Case 2 is for activity level and goals. We map over the activity levels array, rendering a styled touchable opacity for each one, updating the personalinfo.activity level on press. We do the same thing for goals, mapping over the goals array and updating the personal information. At the bottom of this tab, we show the calorie info session. We provide a descriptive test and then, if all required data fields are present, we display the dynamically calculated target calories by calling the calculated target calories function inside the calculated calories view. Case 3 is for dietary preferences. We display the title and description and then a section for dietary restrictions. We map over the predefined dietary restrictions array. Each one is a touchable opacity styled as a checkbox, which calls toggle dietary restriction on press. We use the Ionicons component to show either a checkmark circle or ellipse outline based on whether the restriction is included in the state array. Below this, we add the custom input. We have a custom input container view. with a text input and an add button as a touchable opacity that calls add custom dietary restriction. We repeat a similar pattern for allergies. The key difference is that allergies are only custom added, and if the personalinfo.allergies.length is greater than 0, we render them as interactive tag views that include a close icon for removal, which calls toggle allergy. The default case simply returns null. Finally, we define the component's main render block. We return a modal component, passing the visible animation type, presentation style, and on request close props. Inside the modal, we use a safe area view. The first chart is the header view, which includes a touchable opacity with an Ionicon's close icon to handle closing the modal, a text component for the title, and an empty view for proper spacing. We add a comment called header. Next is the progress bar section. We use a container view with the main progress bar view. Inside the progress bar, we have the progress fill view, where we dynamically set the width style property using a template string. Below that, we show the current step number with a text component. For the content, we use a scroll view that calls the render step function inside it. Finally, the footer view contains the navigation buttons. We conditionally render the back button using current step greater than 0. The next button's text changes to complete if it's the final step using a ternary operator, and its style is also conditionally changed to complete button when the setup is finished. Both call handle back or handle next on press respectively. Outside the function, we define the styles .stylesheet.create block with various style objects to make our component look great. We finish with export default personal info modal semicolon. Now that the personal info modal is complete, we'll switch over to the main AI food recommendation screen, which we'll call AI food recommendation. First, we imagine we're back in the main page file, and we would import AI food recommendation from its components path. We are now looking at the render content function within the AI food recommendation component, which will contain the conditional rendering logic. The first conditional check is for the is loading state. This state is true when the AI is actively generating recommendations. Inside this view, we'll place an activity indicator with a large size and a green color. Underneath that, a text component will display a friendly message, generating personalized recommendations. Next, we handle the initial empty state after loading is complete. We check if the recommendations.length is equal to 0. If it is, we need to guide the user on what to do next. We show a large Ionicons for a restaurant outline, followed by a text title, AI recommendations, and a descriptive text explaining the feature. Inside this empty state, we have a series of conditional blocks based on the user's setup status. The first is to check if the user has completed their profile. We use not has completed setup to check if the profile setup is incomplete. Inside this view, we have a text title, complete your profile, and a text description explaining which details are required. Then there's a touchable opacity that calls on press. The button has an Ionicons for person add and a text for complete profile setup. The second block checks if the profile is complete, but the API key is missing. We present a text title, set up AI recommendations, and a description instructing the user to add their Gemini API key. The buttons on press handler will close the current modal and then navigate to the settings screen. The button itself contains an Ionicons for key and a text for add API key. The third block is shown when both conditions are met. We show a title ready for AI recommendations and a description encouraging them to generate suggestions. The touchable opacity calls the generate recommendations function on press. The button contains an Ionicons for bulb and a text for generate AI recommendations. If the recommendations dot length is greater than 0, we move to the section that displays the meal suggestions. We are now going to return a scroll view. This component is essential for allowing the content to be scrolled if it exceeds the screen height. For the scroll view, we add the property shows. Vertical scroll indicator equals false. This property, when set to false, prevents the vertical scroll bar from showing up on the side of the screen, providing a cleaner user interface. Inside the scroll view, we start with a view that serves as a header for the recommendations. We show the title AI recommendations and the subtitle personalized for the user. Next, we conditionally render a view only if personal info exists. This block displays the key profile metrics in a concise format: age, gender, weight, and height. Following this, we have another view that holds our list of recommendations. We map over the recommendations array, and for each food item, we render a food card component, passing the food object as a prop and using the food.id as the unique key. Finally, inside the scroll view, we have a touchable opacity for the user to generate a new set of recommendations. The onPress calls the generate recommendations function. It includes an icon for refresh and a text that says generate new recommendations. Now for the main return block of the AI food recommendation component, we return a modal configuring its visibility, animation, presentation, and close request handlers. Inside the modal, we use a safe area view. The first child is a view for the header. It contains a touchable opacity to close the modal with a close icons, a text component with the title AI food recommendations, and an empty view for alignment. The content is then rendered by calling our render content function. We finish the component with export default AI food recommendation semicolon. Now let's create the styles object for the AI food recommendation screen. We start the style sheet dot create block with our main container style. To organize our styles, we'll split the screen. On the left, we'll have the component code, and on the right, the styles we're defining. Let's apply the container style to the safe area view component. Next, let's add the styles for the modal header. We define modal header. We'll apply this modal header style to the first child view element right after the safe area view component. We define modal title to style the title text. Now for the styles related to the various conditional states, we have a loading container which centers its content using flex:1, justify content:center, and align items:center. The loading text provides styling for the message. The empty container is similar to the loading container. Empty title and empty description provide the text styling for the message when there are no recommendations. The setup section centers the text within the empty state. We style the setup title and the setup description. The setup button is for the complete profile setup action. We define its background color, padding, and layout as a row with a gap of 8. The setup button text styles the white bold text. The generate button and generate button text are similar but use a different blue color for the add API key and generate recommendations actions. Next, the styles for the main content when recommendations are available. Recommendations container will take up the flexible space. The header styles the general padding. Header title is the main title, and header subtitle is the personalized text. The profile info style is a background box for the user's detailed stats, and profile text styles the information inside. We define recommendations list and the styles for the food card component itself. Inside the card, we have food header with space between justification and then food name and food calories to style the food title and calorie count. Finally, nutrition info, nutrition item, nutrition label, and nutrition value style the macronutrient breakdown. The regenerate button styles the button at the bottom of the list for getting new recommendations, making it green and centered. Let's scroll to the food card component and add the styles we just created. We apply food card style to the outer touchable opacity. Then we apply food header style to the inner view of the food header. For the two text components within the header, we add food name and food calorie styles respectively. In the second view, which shows the macronutrients, we add the nutrition info style. Inside this, each macronutrients view gets nutrition item, and its text children get nutrition label and nutrition value. We repeat this for protein, carbs, and fat. Now we go back to the isLoading section. We'll add loading container style to the outer view and loading text to the text component. In the section where recommendations dot length is equal to 0, we add empty container to the main view, empty title to the title text, and empty description to the descriptive text. Next, in the not has completed setup section, we apply setup section to the outer view, setup title to the title text, setup description to the description text, and setup button with setup button text. To the touchable opacity and its text child. The section where has completed setup is true and has API key is not true also receives these styles: setup section, setup title, setup description, and setup button with setup button text. The final setup section, where both has completed setup and has API key true, uses setup section, setup title, setup description, but this time it uses generate button and generate button text for the action button. Finally, let's move to the main scroll view content block. We add the recommendations container style to the first wrapper view. Inside this, the first child view gets the header style, the title text gets header title, and the subtitle text gets header subtitle. Inside the conditional personal info view, we apply the profile info style and the profile text style to the nested text elements. the view wrapping the recommendations .map gets the recommendations list style. And for the final touchable opacity that calls generate recommendations, we apply the regenerate button style, and the text inside it gets the regenerate button text style. Now we are back to the meal screen component, which is where we will bring all the components we have created together. We are essentially on the home page for meal login. We start by importing our new components and services. Import AI food recommendation from @components/AI food recommendation, and also the use meal plan custom hook and storage service. We also import ionicons and the standard React Native components. We define the meal screen component. We initialize several state variables using useState and default value as false. Show AI recommendations, show custom meal modal, and is loading. We also have selected meal ID set to null, and custom meal data initialized with empty strings for all its fields: name, calories, protein, carbs, and fat. We also initialize two status flags: has completed setup and has API key, both to false. Alright, we use the use meal plan custom hook to get all the necessary context values: meals, update meal, remove meal, get total nutrition, add custom meal, clear all meals, personal info, and a separate context loading flag. We calculate total nutrition by calling get total nutrition. We use the use effect hook to run check setup status once when the component mounts. The check setup status is an async function. It uses promise.all to simultaneously check the storage for both the completion status of the profile and the Gemini API key. We then update our state using set has completed setup and set has API key. We also include a basic try catch block for error logging. The handle select food function takes a food object. If a selected meal aid exists, it calls update meal from the context, then closes the AI recommendations modal and resets selected meal aid. We have three handler functions for managing meal removal: handle remove meal and handle clear all meals. Both use alert.alert to prompt the user for confirmation before calling remove meal or clear all meals respectively, using the destructive button style. The handle add custom meal function first validates that a name and calories have been entered. It then passes all the input strings into integers, defaulting to 0 if the input is empty or invalid. If a selected meal aid exists, it calls add custom meal from the context and then closes the custom meal modal and resets the state. The handle AI recommendations function controls when the AI modal opens. It checks for two prerequisites. If not has completed setup, it shows an alert.alert prompting the user to complete their profile setup, and one of the button options opens the AI recommendations modal. If not has API key, it alerts the user to add their Gemini API key with a button to navigate to settings. If both checks pass, it simply sets show AI recommendations to true. We define two helper components inside meals screen. The meal item component takes a meal object as a prop. It renders a structured view showing the meal title and time. It also includes action buttons, a remove button with an ionicons trash outline, which is conditionally rendered if meal.hasFood is true, and an add button with an ionicons add circle outline. The add button on press sets the selected meal ID to the meal's ID and opens the AI recommendations modal. If meal.food is present, it displays the food name and a row of nutrition details. Otherwise, it shows an empty meal message. The nutrition summary component renders the total nutrition consumed for the day. It uses the total nutrition object to show calories, protein, carbs, and fat in a grid. Crucially, if personal info exists, it displays the calorie target and a progress bar, where the progress fill width is dynamically calculated as the percentage of consumed calories versus the target calories, clamped at 100%. The custom meal modal is a small component that renders a modal for manual meal entry. It has a header with a close button and a title. The body is a scroll view with text input fields for meal name, calories, protein, carbs, and fat. The unchanged text handlers update the custom meal data state. Now back to the layout page. Inside the tabs directory, we are going to set up the meals page and render it. The meal is showing on the iOS simulator now. The header view contains the title My Meals and the header actions view with buttons for clear all meals with a trash outline icon and a placeholder button for the calendar with a calendar outline icon. We then render the nutrition summary component. Next, a meals container view holds the section title of today's meals, followed by mapping over the meals array to render a meal item for each. The quick actions view contains two touchable opacity buttons. The first is for AI recommendations, calling handle AI recommendations on press, and its text is conditional based on has completed setup. The second is for add custom meal, which sets the selected meal ID to breakfast by default and opens the custom meal modal. Finally, we render both our AI food recommendation modal and the custom meal modal at the bottom, passing the required props for visibility and handlers. Thanks for watching this far. That brings us to the end of part 2 of this tutorial. Don't forget to like, share, and subscribe, and stay tuned for part 3.